Let's talk about AI. We've all been there, right? You ask a model a question and it spits out this super long, incredibly detailed answer. And you think, wow, this thing must be really smart. But what if I told you that judging an AI by the length of its answer is, well, completely wrong? Today, we're diving into some wild new research that gives us a brand new way to peek inside the mind of an AI.
So let me ask you this. Doesn't it just feel right? You see more words, more steps, more explanation. It's got to mean more thought and a better, more accurate answer. That's the assumption most of us are working with, for sure.
But here's the twist. Some incredible research from folks at Google and the University of Virginia shows this idea isn't just a little bit wrong, it's often the complete opposite of what's true. Longer doesn't just not mean better. Sometimes it's a huge red flag that the AI is actually getting lost.
And that brings us to this big problem in AI development, something the researchers have dubbed overthinking. It's this weird situation where the very thing we thought was a sign of smarts, a really long and winding thought process, is actually a symptom that the AI is confused.
Now, just look at the data. I mean, the proof is right here. When they tested these models on some really tough math and science problems, they found this unmistakable negative correlation. See that line going down? As the token count, which is basically just the word count, goes up, the accuracy, it actually goes down.
And this quote from the paper just nails it. The researchers put it perfectly. When an AI overthinks, it's not actually doing deeper, more meaningful work. A lot of the time, it's just spinning its wheels, getting obsessed with the wrong details, or even taking its own tiny mistakes and blowing them up into huge errors.
So, if length is a totally bogus metric, how in the world can we tell if an AI is actually reasoning well? Well, to answer that, we have to go deeper. And I mean that literally. We've got to go inside the model's architecture to see how the magic really happens.
Think of a large language model kind of like a skyscraper for ideas. When it's trying to come up with the next word or token, the initial thought is just a rough draft on the ground floor. But as that idea travels up through hundreds of different layers, it gets tweaked, refined, and revised until the final polished prediction gets made way up on the top floor. And that whole layered process, that's the clue. What if instead of just measuring how long the final answer is, we could measure how much work the AI is doing between all those layers? This is where the researchers came up with a totally brilliant new idea, to measure the quality of an AI's effort.
They came up with this concept they call deep thinking tokens. Now, these are the heavy hitters. They're the crucial words or numbers in an answer that the AI has to work really hard on. These aren't the things that get decided easily in the early layers. No, these get constantly reevaluated all the way up to the very deepest parts of the model.
So it's all about separating the easy stuff from the hard stuff. Easy tokens like and or is. The model figures those out almost instantly in the early layers. But the deep thinking tokens, the actual meat of the answer, like the number 13 in a math problem, or the correct choice D, those only get locked in after some seriously intense processing through those top layers. And get this, they can actually see this happening. They call this a heat map of thought. It's incredible. That vertical axis shows you the layers, from the bottom to the top. See all that bright yellow? That's an easy token the AI settled on right away. But look at those dark orange pillars. Those are the deep thinking tokens, where the model had to grind it out all the way to the very end. From all this, they created this simple but incredibly powerful new metric, the deep thinking ratio, or DTR. It's really just the percentage of those hard, deep thinking tokens in an AI's response. So a higher DTR means the model pointed more of its brainpower at the toughest parts of the problem.
Okay, so does this fancy new metric actually work? Is it really a better sign of a correct answer than just counting words? Well, this is where it gets really exciting. The results are just crystal clear.
Just look at this side by side. On the left, that's what we saw before. Answer length goes up, accuracy goes down, it's a total mess. But now, look at the chart on the right for the deep thinking ratio. It's this beautiful, clean, upward line. It's a strong, positive correlation. The more the model thinks deep, the more likely it is to be right. It's that simple.
And the numbers don't lie. Answer length has a negative correlation with accuracy, but the deep thinking ratio, a jaw-droppingly strong positive correlation of 0.828. This isn't just a little better, this is a total game changer for how we understand AI reasoning.
Now, this is way more than just a cool finding for a research paper. This has huge, practical consequences for building better, faster, and, get this, cheaper AI systems. Let's dig into why this matters so much.
So using this new insight, the researchers built a whole new strategy called Think at N. The idea is pretty clever. Instead of having the AI generate one super long answer, you have it generate a bunch of shorter ones. And then you use DTR as a filter to instantly find the answers where the AI was thinking most efficiently.
And here is the real kicker. By using DTR to spot the best answers and just throw away the rest, this method can get even better results while cutting the amount of computation you need by roughly half. That's a massive, massive gain in efficiency.
This chart just says it all. The standard way of doing things gets you pretty high accuracy, but man, it costs a ton in computer power. The new Think at N method, though, it actually gets you even higher accuracy for a fraction of the cost. It's about working smarter, not just bigger.
So, after all that, what's the one big thing you should take away from all this? It's a huge shift in how we should be thinking about what makes an AI intelligent.
The authors themselves put it best. We need to stop looking at surface-level stuff like how long an answer is and start measuring what's actually going on under the hood. It's not about how long an AI thinks. It's all about how it thinks. That's the real path forward.
Which leaves us with this one final, really interesting question. For years, the big race in AI has just been about building bigger and bigger models. But maybe this research points us to a whole new frontier, one where the goal isn't just about creating massive AI brains, but about teaching them how to be more focused, more efficient, and just plain better thinkers.